Thank you, everyone. Thanks for coming out on this last day of SREcon. I know people are tired, so please bear with me. I did want to try to make this a little bit more interactive, so I did set up some audience interaction points, like, for example, this first one. Oh man, the question is cut off at the top. Uh-oh. Is there any way we can, the resolution, I mean, the slides are coming, whatever. The question is, what role does caching play at your company? And you can actually go to slido.com and put in the event code cache, and you can actually vote. And there will be a couple of these throughout the presentation. It kind of is purely kind of for my own fun and edification, but feel free to participate if you are interested. Yeah. Cool. I mean, this first one is more like a, getting a pulse of the audience for fun. But yeah, sounds like everyone, we have a majority of people who cache everything. All right. That being said, let's move on to the presentation. So my name is James. I've actually joined LinkedIn in 2013. Since then, I've been a SRE for multiple teams. I've worked on things like the LinkedIn Learning product. I've worked on the profile page, a bunch of different things. But most recently, I'm part of the caching as a service team at LinkedIn. I love Python. Try to write as much code in Python as possible. And I am a Vim user. I don't know how many other Vim users there are out there, but I think it's awesome. Cool. So let's start to get a little more serious. This question, the second question, oh man, it's cut off again. I guess all these questions will have the top part cut off. But the question is, what caching solution are you currently using at your company? Interesting. I did not expect Redis to be the majority, but okay, cool. So I don't know if you guys know what we use at LinkedIn. We've actually written several blog posts about what we use, but we basically use Couchbase at LinkedIn. However, I just wanted to preface this by this is not a talk about Couchbase. I love Couchbase, and I can talk about Couchbase for hours. If you want to talk to me later about why Couchbase is so cool and why it works so well at LinkedIn, feel free to talk to me. But this talk is more about general techniques that can be applied anywhere, regardless of what caching technology you are using. That's one of the blog posts that we have written that talks more about Couchbase at LinkedIn, so feel free to check that out. I first want to talk about the history of caching at LinkedIn and how we got to where we are today. So this is back in like 2012, 2013, where originally we were using memcached, and we're getting to a point where teams were getting frustrated with operating memcached. For example, one of the most common issues were when either host died or maybe the memcached process died. Teams were frustrated that they would lose a portion of their cache in those instances, and there was no way to recover from it because it was an in-memory cache. Also, resizing, let's say you wanted to expand the memcached cluster, or if you needed to replace hosts, this was difficult due to the way that it would break the hash ring. And finally, if I ever needed to copy the contents of the cache to some other cluster, for example, for a new data center build out, this was really difficult. We did come up with some hacky ways to do this, such as doing things like brute forcing keys and stuff like that, but there was no easy, out-of-the-box solution for doing this. So the reason why we decided to go with Couchbase at the time was it was initially advertised to us as a drop-in replacement to memcached. So you were still able to use the memcache client libraries and talk to Couchbase transparently, and Couchbase would translate the memcache binary protocol to the Couchbase binary protocol, and it would just work out of the box. But not only that, it was also very fast. It actually had persistence, so across node restarts, and whatnot, it would still maintain the contents of the cache. It also supported the concept of replicas, so that if you had a single node failure, you can activate replicas on a different node. And finally, it was also really good at resizing. So if you needed to expand or reduce the size of the cluster, there was a very transparent way to do that, and it was supported out of the box rather than you having to like manage node lists and whatnot. So because of this, Couchbase adoption really exploded at LinkedIn. We actually ended up creating a virtual team or a working group to share learnings and to kind of come up with good best practices on how to use Couchbase at LinkedIn. And over time, this got to a point where we had over 2,000 hosts in productions. We had over 300 unique clusters. And these were managed by individual SRE teams. So for example, I was speaking earlier that I was used to be part of the LinkedIn Learning team. So LinkedIn Learning would have their own Couchbase cluster for their services to cache whatever they needed. Maybe the profile team would have their own Couchbase cluster and for their own needs. So there's a lot of clusters and a lot of hosts. It got to the point, though, where we were questioning whether we were growing too fast. And the reason why that happened was because, first of all, the number of site outages that we started to have because of Couchbase started to increase. And we started looking at why this was happening. And it was largely due to the fact that a lot of teams weren't properly maintaining their clusters. And for example, like let's say nodes would fail and they would just kind of not do anything about it. And although like that would mean that the part of your cache would still work, they would just let that be until maybe additional nodes went down, and that would cause a larger outage. Ultimately, I think people were looking for like a black box solution for caching where they can just send requests to and it would just work, and they didn't have to worry about how like maintaining it and making sure things were up to date. Also, we had a custom deployment method for building out these clusters and maintaining them. LinkedIn, we have a deployment system that pretty much all of the apps used. But Couchbase was kind of in its own world where we had our own custom thing due to the manner in which Couchbase was introduced to LinkedIn. So we weren't even using standard deployment tooling that the rest of the company was using, and so which increased the barrier to entry for other people to get more acclimated with Couchbase. So it was difficult. For example, another thing that was difficult because of this custom tooling was pushing upgrades. Rather than being able to transparently upgrade the nodes of your Couchbase cluster, we would end up having to do like an offline upgrade, which meant like taking down the entire cluster, upgrading all of the nodes, and bringing it back up with some kind of planned maintenance window, which was definitely less than ideal. And finally, we also had runaway hardware growth because, as I said before, each team had their own Couchbase cluster. So multi-tenancy was just out the window. There were many clusters where there was just one use case on that cluster, and there was a bunch of excess capacity that wasn't being used. And this was definitely a place where we've realized we're just dropping money on the floor by doing this. Cool. So the next question. I'm just curious how the question is, how does your company manage caching? So I kind of explained how we did it and some of the challenges that we ran into. But I'm just curious as to how the rest of you guys, or how the rest of y'all are doing caching within your own companies. Okay? Sounds like a lot of people every team is for themselves. Okay. So I guess the next up is we finally decided, hey, we need to build out a team and offer caching as a service. We decided that we wanted to centralize the caching infrastructure to a team that is passionate about caching and wants to solve caching at scale. There are a lot of, like I said before, there's a lot of teams that just wanted to use caching as a black box. And we wanted to provide a platform in which people can do that, and it abstracts all of the details of maintaining and managing caches under the hood. Before I move on, I just wanted to quickly talk about some Couchbase specific terminology, as I'm going to be using it for the rest of the presentation. So in Couchbase, you have documents, which are things that you want to store in Couchbase. Buckets are your logical resources. So usually we have a bucket allocated for a given use case, for a given application, for example. And these buckets, you can have multiple buckets, and they're distributed across clusters. So clusters are the things that are comprised of hosts, but within a given cluster, you have logical buckets. And those buckets are used by individual applications to write documents. So one of the things that we wanted to make sure we did as we offered caching as a service was we wanted to build and manage these clusters at scale. We wanted to treat our clusters like cattle, not pets. We wanted to make sure that we had tooling to operate on multiple clusters at a time. It was before with this self-managed every team for themselves model. Because most of the teams only owned one cluster, it was very often people would do things manually, and it would be sufficient because they only had to do it from one cluster. But we knew that we wanted to do things across tens or hundreds or maybe multiple hundreds of clusters at once. And we wanted to make sure that we were building our infrastructure to do that from the ground up. We also wanted to improve our hardware efficiency. I think I was talking about this earlier about being able to pack more use cases into a given cluster and have truly multi-tenant clusters. And security was another thing that we wanted to do as well. We wanted to standardize how we secured Couchbase at LinkedIn, whether that was using certificate-based authentication, for example, as well as other improvements that we wanted to do, which was a lot harder to push out when each team managed their own clusters. So it was hard to push out initiatives to say, hey, we should do something to all of our Couchbase clusters, because each team, the ownership of each cluster was with each individual team. And finally, we also decided to purchase enterprise support from Couchbase. We were actually running the open source community edition of Couchbase, and because we were running at such scale, even with our self-managed clusters, there was a lot of bugs that we actually discovered with Couchbase that we were able to open with Couchbase, but because we didn't have a support contract, we realized that there was not much leverage that we had with them, and there wasn't any incentive for them to be expeditious about taking care of our needs. So we came up with a mission, and CAS, if it isn't clear, it stands for Caching as a Service. Our mission statement is to provide secure, high performance, and cost-effective caching to all teams within LinkedIn. And we're going to go into exactly how we decided to do that. So let's go to the next question. The question is, what latencies do you see from your data stores? This is not from your caches. This is from, if you didn't have a cache, what kind of latencies do you see from your data stores? OK. Interesting. 10 milliseconds is pretty fast for your data store, especially if you have maybe a more expensive query that's doing maybe multiple joins or whatnot. But OK. I just wanted to say that this is one of the reasons why caching is important. We typically see from our source of truth data stores that the latencies from these data stores can range anywhere from 10 milliseconds to multiple seconds, depending on how expensive the query is. And caching really benefits these use cases. One thing that is kind of funny that sometimes people come when they want to onboard onto our platform is they ask, hey, we really want to onboard with Couchbase, but we have a lot of hot keys. Or we have a couple keys that are very, very hot, and we might be sending tens or even hundreds of thousands of requests per second to these keys. Is that OK? And I think the answer is that's exactly what caches are for. Like, it's to accommodate hotkeys. Like, that's when caches perform excellently. That's when your hit rate is really high. So that's really where caches can really shine. Next question is, what latencies do you target for your single key gets? So this is, regardless of what your data stores have for their latencies, like, what do you want ideally? I guess we would ideally all want one millisecond latencies, but okay, maybe that was a kind of a redundant question. So I guess with that being said, I wanted to show what we offered as a service to all of our teams within LinkedIn. We offer between 0 to 1 millisecond. So when I say 0, it's because it's less than 1 millisecond, and it's measured in the order of nanoseconds. But it's some of our systems don't have the granularity to show that, so we just measure everything in milliseconds and say that we offer 0 to 1 millisecond 95th percentile latency for get and set operations. It's actually even better than that. This is kind of what we advertise to our clients, but looking at our data, it's 0 to 1, even up to like our 99th percentile latencies. Our SLO that we provide to our clients is 10 milliseconds, but once again, it's very, very rare that we see it go up to 10. We came up with this 10 number because we did some performance testing where we put the cluster into a really contrived state to explicitly, intentionally try to break the cluster and cause it to perform poorly. And we managed to get it to perform in 10 milliseconds, but by far in normal day-to-day operation, it does not go anywhere close to 10 milliseconds. And we've actually recently started offering things like replication, which means like cross data center replication, as well as indexing. And I'll talk a little bit more about why we decided to do that. In addition, we decided to, we actually have separate classes of clusters. We have SSD-based clusters, standard spinning disk-based clusters, and also pure memory-based clusters. And these are separate types of clusters, and some of our clients they come to us and say, hey, we want to be on the fastest thing possible or that you guys have. But this is really something that's kind of abstracted away from our clients. It's something that we decide to do depending on what usage characteristics your use case has. And it really, this basically allows us to have further cost savings where if a given use case is not as important, maybe not as many requests per second, maybe a very small data set, then we can put it on lesser performing hardware and reserve our higher performing hardware for our higher capacity needs. Also, we get informational dashboards for free. So we actually collect server side and client side couch-based specific metrics, and we pipe them over to our metrics gathering system, and that is exposed, and we automatically generate dashboards based off of those metrics, and we expose those to our clients. So if people want to, if our clients say, hey, like, I see weird couch-based specific latencies or whatnot, we can say, hey, like, look at this dashboard. Like, and if you see something wrong, then you can reach out to us. Also, we alert on the health and the availability of the cluster. This is something that now kind of goes along the lines of me saying that we wanted to offer caching as a black box. It's, for example, if nodes die within a given cluster, or if nodes, for example, another thing that we see is that SSDs start dying. Like, they're not dead, but they start dying in the sense of that they start performing poorly. We have alerts and metrics on that, and we are able to do that. And once again, we're also able to handle hardware failures, whether that's on the host level, switch level. These are all things that, and finally also software and OS upgrades as well. So these are all things that we were able to do. Sorry, I lost my train of thought. So for software and OS upgrades, this is something that very rarely happened in our self-managed clusters. But now we were able to orchestrate and to automate these upgrades so that we're able to flip a config value in our config and kick off a deployment, and each node would go and remove itself from its cluster, upgrade itself, and rejoin the cluster. So it was something that was very difficult, and we had to do offline upgrades in the past, and we were able to automate this, and it would transparently happen through regular business hours, during peak traffic, and it would just work. Let's see. So this is some more metrics that we provide. Unfortunately, I had to hide the legends because our comms team didn't want me to show that. But so this is just for the visual effect of what kind of metrics are available. And this is what our clients see when they want to know more about their bucket. One thing that I want to specify is what we don't offer. We don't own the data that our clients put into it. I think this is important to state because at the end of the day, we're just a platform to store your data. We're not going to monitor the contents of your cache, for example. Like we're not going to say, let's say we suddenly see a drop in your hit rate. We're not monitoring that, and we're not going to be like, hey, why did your hit rate suddenly drop? Because we don't know. We don't know whether that's something that's valid. We don't know if that was intentional or whether it's not. So we only monitor whether or not the cluster is available and healthy. Because at the end of the day, you own your data, and we don't know what's acceptable for your application. And another thing, too, is that we don't take backups. This is somewhat of a controversial point initially, because people were saying that we should take backups to be more resilient and more available in the case of a catastrophic outage. But we think that it's a good thing that we don't, because it prevents people from using us as a persistent, durable store. We actually have multiple solutions already within LinkedIn for persistent storage and for different use cases. And by not taking backups, we're able to focus on occupying the caching space within LinkedIn only, rather than expanding and kind of stepping on other data stores' toes. To provide some sort of numbers of how much we're caching, we've onboarded a bunch of use cases onto our platform, and right now we have over 200 unique use cases in prod, and of varying sizes. Small ones that do no more than, I don't know, 10 queries per second, all the way up to use cases that do several million. It spans across 2,000 hosts, and in aggregate, we see somewhere on the order of about 10 million QPS across multiple clusters. Wanted to talk about some challenges that we saw. Next question is, what percentage of your time in 2018 did you spend on GDPR related stuff? Interesting. OK, I guess a lot of teams maybe were already GDPR compliant and didn't need to do anything, which is nice. I personally had to do a bunch of stuff. So one of the challenges that we ran into was we needed to ensure GDPR compliance over a bunch of caching use cases within LinkedIn. This was before we actually formulated our dedicated caching team. And it was, although there were multiple paths to gain GDPR compliance for caches, the easiest solution was to migrate onto our managed platform. So we really think that a win was that we created this dedicated caching team to help drive GDPR compliance by migrating onto our platform. The problem with these self-managed clusters were that they were in a lot of different states of updates as well as maintenance, which meant that really nothing was standardized. So to basically say, hey, for GDPR compliance, you need to do X, Y, and Z, it was, people didn't, first of all, didn't even know whether or not, if they were already compliant or if they needed to do anything. But by migrating onto our platform, it now became our problem to make sure that all of our clusters, as well as things like authorization and authentication, was taken care of on our end, and we could enforce that. Another challenge that we ran into was we decided to change the way we did deployments. The old way that I kind of alluded to earlier about how difficult it was to do this custom deployment was that we had to first hand edit some configuration files. We had to commit them and wait for them to sync, which could take anywhere from 30 minutes to an hour. And we had to run this non-standard salt-based runner to build the cluster and just pray that it works. And a lot of the times it didn't. And when it didn't, you'd go back to step one and edit your configuration files again in hopes that you could fix something that you missed the first time. And although this worked, especially when you just needed to build one cluster for your team, we were building out clusters, like multiple clusters in a given week, in a given day even. And we wanted to make sure this was a little bit more robust, and also that we wanted to use standard LinkedIn tooling so that we can get support from all the in-house goodness that we have. So we decided to create a wrapper around the Couchbase server product, and that would hook into our standard deployment infrastructure. And this would allow us to use standard deployment tooling for actions like upgrades, cluster expansions, and whatnot. And just wanted to emphasize how awesome this is. Basically, like from the perspective of the end user, like from anyone on my team, we would just click a button to deploy, just kick off a deployment like any other deployment. And what would happen under the hood is that each node would fail itself out of the cluster, shut itself down, do the upgrade, and rebalance itself back into the cluster, and then the second node would do it. And it was completely transparent. And then although this upgrade operation could take maybe hours, multiple hours, from our perspective, we just needed to kick off a deployment like any other. And it would just take longer than it normally would because it was doing this failing out and rebalancing back in operation. Another challenge that we ran into was that we were running as root. I mean, I think in a lot of situations this might be OK, but at least how we run things at LinkedIn is that we actually run as a dedicated application user. And we were kind of an anti-pattern to be running as root across all of our infrastructure. And the reason why we just didn't start running as root from the beginning was because the Couchbase, the company, didn't officially support it. And there were some hacky ways to do it, but we wanted to make sure we complied with the official way of doing things so that we didn't violate our support contract and whatnot. But also, we were a small team. We're just getting started. We had this huge task of migrating all these use cases onto our platform. And we just needed to ship something quickly for our first iteration. And we knew that over time, in the long run, we had to switch to to not be running as root. And also, because the old way of deploying these self-managed clusters were RPM-based, we knew that if we just continue doing that, that was a path that we were familiar with and that we were already accustomed to. So we decided to just do that in the beginning, get it out the door, knowing that we would need to fix this in the future. So we were actually managed to get off of root actually, but it was pretty difficult, or it was difficult to make sure all the pieces were in place before we were able to actually execute this. And I think it's equivalent to try to switch out the engine of a car going at 100 miles an hour, or I guess it's kilometers per hour here. And we basically decided that we wanted to do in-place conversions to convert a root node into a non-root node. So we actually ended up reusing a lot of our upgrade automation, because in essence, that's what we were doing, right? We were taking a node out of a cluster. Normally, you would shut it down and upgrade the version, like the software of that node. But instead of doing that, we were doing things like changing file permissions, owning maybe directories, and maybe creating symlinks from the old paths to the new paths. And ultimately, this led to us switching to tarball-based deployments, which is vastly what most of LinkedIn is doing, and it's much more within, it's part of the standard way of doing things at LinkedIn. And once we were able to do this, we were able to just kick off a deployment like any other, and it just went through each node, removing it, doing this conversion, and putting it back into the cluster. And we were able to do this transparently during regular business hours. And once we were done, our clients didn't even notice, but we were running completely as not the root user. And once we're done, we were able to remove over 1,000 lines of code, which was awesome because we had a lot of custom code to handle this root stuff because it wasn't part of our normal deployment infrastructure. Some takeaways that I wanted to talk about is that I guess the number one is to treat your clusters as cattle, not pets. I was talking about this earlier, but it really is important because it affects the way that you think about automation and scale. I think it's really easy to babysit a cluster and make sure it's taken care of manually, especially when you only own one cluster, giving it your tender, loving care. But once you start dealing with tens or even hundreds of clusters like that, you can't manually SSH into every cluster and take care of it. Like, it's just not scalable. So really trying to standardize things across the board and standardizing things, whether it's naming, whether it's configuration, really allows you to make assumptions about your infrastructure to reduce complexity. I think one example that I can give is initially we were thinking of for more of our bigger, more important use cases, we were thinking, hey, maybe we should give these clusters special names, right? Like maybe this cluster is should be the, I don't know, it should have a name that's specific to the application, so we know, oh, this one is an important cluster. Like we shouldn't, this one we need to treat specially. But we actually decided that we should just continue with our naming convention that we've been using. We've been naming our clusters like SSD1, SSD2, SSD3 for SSD-based clusters, and HDD1, HDD2, and so forth for our spinning disk-based clusters. And we decided, hey, even though this is like a really important use case that if this goes down, like LinkedIn would be impacted, we're still going to continue naming this cluster, I don't know, SSD16 or whatnot. Because at the end of the day, by standardizing, we were able to know that these SSD clusters, we all treat them separately, whether or not it has the most important use case ever, or whether it has a very insignificant use case. It keeps things simple from our perspective. Another thing that was important for us is that we decided to start with the core offering and to iterate on it. We knew that we were good with offering a key value service. And this is what we initially started with when we built out the caching as a service team. And eventually we saw that there was a business needs to offer things like replication across data centers or even indexing the data, the value of the documents that are in the cache as business needs grew. And we knew that, hey, although this kind of isn't exactly what a cache is in terms of just at the core of it being a key value store, we decided, hey, this is something that can really benefit the business, and we are offering it now for our customers. Another important point that we learned was that we needed to codify checklists into automation. I think runbooks and checklists are OK. I think they're great. But I think once it's down and documented and it works 100% of the time, you really, or not even maybe not even 100% of the time, but you need to make sure that you're striving towards automating it and getting rid of the runbook. You really want to reduce the amount of time spent on manual tasks, or you're really going to fall behind. Like you don't want to spend all your tasks doing things that you know exactly how to do and following steps of some sort of document. And if you don't have runbooks, I think it's important to create those first. I think some people, we've had instances where we were like, oh, this person is the person who knows how to do things. And if we ever run into this specific issue, we should reach out to this person. And we really shouldn't rely on people to know how to do things. That really is a single point of failure that we don't want to make ourselves liable to. Instead, we should document, as a first step, what that person knows, and then ultimately codify this into your automation. So one thing that I wanted to show you was the process of what it was like to originally add a bucket manually into a given Couchbase cluster, and kind of show what we've decided to do. So for example, this is the Couchbase UI, and let me see if this works. Yeah, so normally you'd create a bucket, give it a name, give it a certain memory quota, and maybe set the number of replicas that you're interested in, and then click Add Bucket. And then at this point, it's not ready yet. You'd actually need to add a user to be able to access this bucket. So you need to do that next. Give it some username and a password, or if we use certificate-based authentication, the password is a no-op. It is not actually used. Give it the correct authorization, and then only then would a bucket be correctly provisioned. And we decided initially that, hey, we need to automate this. Like, this is a no-brainer. There's no reason for us to do this by hand, and especially doing this across multiple data centers. Like, there was so much room for human error, and this is not a scalable way to do things. So our first iteration on this was we decided to say, hey, let's just stick our bucket configuration into our configs. So it would look something like this, where we said, hey, this is the entry for one bucket, where we decided to say, hey, we're going to create a bucket called TSAP tracking fast dedupe. Give it the RAMs, the quota, the number of replicas, the type of bucket it is, what kind of eviction policy it has, and the users that are authorized to talk to that bucket. And it worked. I mean, basically, when you wanted to add a new bucket, you would add a bunch of configs into the application configs, commit it, then do a deployment, which would then see that this config is new and the bucket doesn't exist, and it would take the necessary actions to create this bucket. But we realized as we needed to create a bunch of buckets at once that this was not really scalable, because we had to deploy configs every time that we needed to add and remove buckets. This was a lot of unnecessary repetition. Ultimately, the idea that this new config really only needed to exist on one host only needed to be aware of this new config, and then it would create the bucket. The automation would create the bucket, but instead we ended up doing a bunch of deployments to all of our nodes when really we only really needed to do it on one host, and then the bucket would be created on the entire cluster. So we actually extracted this logic out from the deployment system, and we put it into a CLI tool. And this is kind of small. But in essence, we created a CLI tool where we can add buckets. I actually wanted to show a demo of this, but there was actually a lot of parts that needed to be redacted, and I decided to just do a screenshot and redact the parts that I wasn't allowed to show. But in essence, we would basically run a command with the correct arguments of what the name of the bucket is, the quota, the authorized users, and it would detect the number of replicas that was optimal for that cluster based on the number of hosts, and create the bucket across multiple data centers. So, and we would have things like a bucket list command where we would be able to list the different buckets across, once again, different data centers, different even environments. Another thing that is important is that we should really be building platforms, not tools. Rather than building tools for specific issues, we should be building general APIs that can be pieced together to solve specific problems. I think one example of this is, rather than taking on the challenge of saying, hey, I want to automate cluster upgrades, and maybe building tooling to specifically automate cluster upgrades, maybe it's better to first expose primitives like being able to fail out a node, to check the node status, or to maybe add a given node to a given cluster, and then creating like a higher order automation which would then use these smaller pieces, these reusable smaller pieces, to create your cluster automation. One example that I can think of that did this incorrectly was that one of my teammates was on a previous team where they had a tool to do cluster maintenance operations, but this tool was provided by the dev team, and it was very tailored specific to specific use cases that they had. So for example, let's say there was some sort of weird state the cluster would get into, and it needed to be fixed in some way, so the dev team would provide a tool that said, okay, run this command when this issue happens. And then there was a different, completely unrelated issue, and the dev team would be like, okay, you can run this tool to remediate this issue. And this is an example of the dev team was providing tools, not a platform. Instead, if they maybe expose an API to do these smaller operations, and then it could have empowered the SREs to build tooling upon these primitives and solve their own problems. And finally, I wanted to say that it's important to trust your automation. It can be tempting to fall back and to doing things the manual way when automation and your tooling fails, and it is bound to fail. But try to refrain from doing that. Use it as an opportunity to figure out the root cause and improve it. Sometimes it feels like it's easy to just say, hey, like, whatever our automation is doing, it's complex, and I don't know what's happening, but I do know how to do it manually. So to get out of this hole, I'm just going to do it manually. But really try to refrain from doing that and use it as an opportunity to understand the automation better and to use the tooling to improve the robustness of the tooling. And finally, talking about some of the future stuff that we're planning on working on. Self-service provisioning is one thing that we wanted to do. Right now, if someone wants to create a new use case, they need to talk to us and submit a questionnaire. And based on the questionnaire response, we would ask either further questions, or if there weren't any further questions, we would run that CLI tool to provision a bucket for them. But this really doesn't need to be an interaction between us. Assuming they meet all the criteria, they should be able to just get a bucket provisioned. And we honestly don't need to be involved. So that's one thing that we're working on. We want to also transparently migrate buckets across clusters. So for example, let's say we initially put a bucket on the lower performing cluster because the use case wasn't that important, or maybe it was a smaller use case. But let's say it grew, and it now needs to be part of a different hardware profile. We want to be able to transparently migrate that bucket to a different cluster and then cut over the client to use the new cluster. We're very close to doing this today, but just some small kinks that we're working out. And also, I didn't know how many hosts actually fail in production. And during my on-call shift, sometimes there's a lot of time when I'm spending single node failures. Like you have a single node that goes down, and I have to remove it from the cluster and replace it with a spare. And right now, it is somewhat of a manual process. But we want to be able to even transparently handle node failures, where if it's not, pingable, or if it's not hitting some sort of health check, just automatically say, hey, this node is dead. Let's remove it and replace it with a good one. And finally, better resource and hardware utilization. This was one of the original goals of this team, but we weren't actually able to do it as much because we were so focused on getting everyone onboarded to our platform. But now that everyone is onboarded, we wanted to spend more time seeing, let's say, for example, where the underutilized buckets are, and either maybe reduce their capacity or move them to a lesser performing cluster, for example. Cool. So that's it for me. That was my presentation. This talk was about building centralized caching infrastructure at scale. Thank you very much. I think we do have some time for some questions. So if you have questions, please come up to the mic.
Hi. How do you manage capacity planning?
So capacity, at least for Couchbase, there's, I guess, two components. One is, let's say, the amount of throughput that it can handle, and the other one is the data set size. So in terms of throughput, Couchbase actually handles that very, very well, and it's very rare for us to see that, let's say, even if your traffic increased by 2x or even 5x, or sometimes even up to 10x, it doesn't affect the cluster too much. But let's say it does. Then we would for example, let's say add nodes or maybe move the bucket to a different cluster. Right now, it is somewhat reactive. It is not proactive at the moment. We do sometimes get heads up from our clients saying, hey, we plan to double the size of our cache or whatever, right? And in that case, we're able to plan for it. And I think it's something that we can work on better as well. But at the moment, it is more of a reactive process than proactive.
Yeah, so I had two questions. So the first one was, you mentioned that you try and avoid this by doing backups, but at what stage, when you've got like cross data center replication and persistence and tiered storage, do you sort of say, well, hey, let's not just use this as a cache, let's use it as a source of truth data store?
Yeah, that's a very good question. You're right. Like, I think as we're able to provide a platform that works very well, that is very fast, that scales really well, there's lots of questions that are like, hey, why can't this do more than just caching? Why can't we just, for example, guarantee durability better and like use this for source of truth related things? I think the short answer to that is those solutions already exist within LinkedIn. There are other solutions that already do that. So there's no point in exposing multiple things that can do the same thing, right? So we really wanted to focus on our niche, which is caching. But I think as we see more and more use cases and requests coming, people coming to us for requests, we see that there is an expanded need for other things besides just caching. For example, another thing that has been coming to us is people using us as a temporal store. So it is a source of truth, but the data is short-lived, right? Like, let's say it's only valid for, let's say, 24 hours. And so technically, if we were to have a catastrophic failure and we lost all the data, like, yes, this is data that's irreplaceable, but I mean, within 24 hours, it should, be okay. So we do have onboarded use cases like that. Another use case that we are starting to kind of see as well is people trying to use us as a very fast message bus. Like, people see that, for example, Kafka is our official message bus within LinkedIn. But sometimes it doesn't fit the use case, and people are like, hey, can we use you guys? And it's not the intended use case, but so yeah. So I think the answer is yes, our initial value proposition is somewhat expanding, but we are also being very careful in where we are expanding to.
And the second question was, I know you guys don't use Kubernetes at LinkedIn, but have you considered looking at it in light of the fact that Couchbase provide a supported operator for spinning up clusters?
Yes. We have looked at it. Unfortunately, it's not going to be like, we can't like take what Couchbase provides to us with the Kubernetes operator and just use it as is. We've actually looked at the code, and it's actually very similar to what we've actually implemented in-house. But unfortunately, because we don't use Kubernetes in-house, it's not something we can just drop in and use.
Cool. Thank you.
I was wondering on, damn it, waiting so long, it dropped out of my head, specific wording. So when you manage your own caches, you care about things like cache warming in cases of failovers or data resets or the likes. How does your team do that? Do you just say it's completely up to the users, or can you help people with things like cache warming and making sure they're ready after a reboot?
So in the case of a single node failure, we actually don't need to wait for a warm-up because we actually activate the replicas, and that replica becomes the primary, and it just starts working. There is no warm-up necessary. When we replace the dead node with the spare, I mean, that there is some warm-up process that happens during that time, but that node doesn't start taking traffic until it's fully warmed up. So warm-up isn't really an issue there. A place where we could see a warm-up issue is, let's say we're building out a new data center or something, and there's nothing in that cluster for that data center. We do sometimes do things like cache copying the data set from a different data center to the new data center. But usually that's not too big of a problem either, because when we build out a new data center, we slowly trickle traffic in, and it kind of organically warms up the cache rather than us having to take specific measures to explicitly warm up the cache.
So I have two questions. So one is, are you guys running Moxie proxy, so to do the memcache translation kind of thing? And the other question is, so when you're doing the rebalancing with the CPU spike and all those the resources usage, will it affect the actual performance of the cluster?
It's very good questions. It's very Couchbase specific, but for the first question is, are we using Moxie proxy? For those of you guys who don't know, Moxie proxy is the translator that translates Memcached protocol calls into Couchbase and the other way around. We originally used it, but there was a lot of stability issues that we saw with it. So we actually migrated from using the Memcached client talking to Couchbase over Moxie to just using the Couchbase SDK natively. And not only did we see huge performance wins, but there's a lot more features that are exposed when you use the Couchbase SDK directly. And then your second question was with rebalancing, do we see performance issues? In earlier versions of Couchbase, yes, we did. And rebalancing was a very disruptive process. But in the more later versions, probably 4, 5, and higher, we've actually seen it to be much more stable. And at this point in time, it's actually a very transparent operation where we just do rebalances all throughout the day, even during peak traffic hours, and our clients don't notice. Cool. Any other questions?
I have a question regarding the upgrade flow that you were talking about. So are all the upgrades driven by your team internally, or do you also allow customization from your users? Because every time a user wants a configuration change, that would be highly customizable. It may not be the same the next time they want to do the upgrade. So how do you handle it?
So what do you mean user customizations? Like, for example, what?
Say, for instance, the cluster that they are using, they want to clean up logs in a certain frequency other than what you propose or provide as a standard offering. So how do you handle such kind of customizations?
I see what you're saying. So I think if this kind of goes back to the standardization point I was making earlier. We really try not to do one-offs because it really makes it harder to keep track of those, as well as to make sure that they're accounted for when you're doing future work, right? So most of the times when it would require us to go outside of what we normally offer, we usually say no. But in the rare instances that we do, it's usually in on a temporary basis for them to figure out how to better fit their use case into our model, rather than a permanent exception that we make for them.
Have you really thought about giving some hooks where they can inject their own script for upgrades, so that goes through your workflow and does the upgrade through your system?
That hasn't been a use case up to now, but I'm sure that if people needed to do that, then we could. That's something that we could offer. Yeah.
And how do you manage the batch size for upgrades? I mean, do you go one machine at a time, or is the number flexible enough?
So it is flexible, but right now we are currently doing one at a time, because we were able to build it into our deployment workflow. Like, it really doesn't matter if it takes minutes or hours or even days, because we just kick it off and it just runs going one at a time. So it's very hands-off for us. So there really hasn't been a need to do more than to increase the parallelism. But if we ever needed to do upgrades faster or whatnot, our code currently supports that today. It's just that we haven't enabled it. Yeah.
Thank you.
Cool. All right. Thank you very much.